Hello dear friends, welcome to another video of the Never Do Through the GUI What You Can Do Through the CLI. I am Vangelis and today you will be watching Rust exploring the Tokio vs async-std performance part 2. So this will be an update video. I will share my new information on the subject. Still I haven't reached a final conclusion, but I have some more information and this is what I will share, and I'm trying to involve here responsible persons. Sorry for this, let me mute this. Responsible persons for the projects, and when I say projects I mean the Tokio and probably the actix-web project. So yeah, let me get into the video and into the information. And the information starts from me contacting Carl, who is the main maintainer of Tokio. And we had a little bit back and forth with Carl. And what came from this conversation are two things. The first thing is that Carl created some benchmark and I tried to reproduce the benchmark. And the benchmark consists of testing the Tokio spawn blocking function, as you can see, and the async-std spawn blocking function again. So we are testing these two APIs of the two runtimes, and the result of this was for Carl, the benchmark he created showed that Tokio was faster, and also in my case, Tokio was also faster when I iterate for 1000 times. So if I run this benchmark, you will see that Tokio will be faster. It will need less time per iteration to complete the benchmark. But if I cut down the iterations and use only 100 iterations, then async-std is faster. So let me perform this for you to see. As you can see, the async-std blocking function, which uses async-std obviously, needed this amount of nanoseconds per iteration, whereas Tokio needed this amount of nanoseconds per iteration. So as you can see, async-std is still faster for this amount of iterations. So what I'm trying to say is that we got a little progress and we created this benchmark, and Carl tested his benchmark and it was faster than async-std. But this is not conclusive because as you see my test here, for n number of iterations one runtime is faster, and for another amount of iterations another runtime is faster. So I'm not really sure how we can extract meaningful or conclusive, let's say, results from the benchmark. So I think that this is, let's say, a call for participation. Let's say I am sharing information and I'm trying to get more people involved, more experienced people involved. I for myself just trying to dig into the subject matter and gather as much information as I can. So this is one point that I want to share, that we created this benchmark, but it seems that this is not a conclusive way of reaching a final conclusion. And the second thing that I did was to update actixweb to the latest release candidate, as you can see, and I updated the whole application here. And what I did is I created a runtime, a Tokio runtime, and I run my application on the Tokio runtime. instead of using actixweb main, etc., I'm explicitly building a Tokio runtime and using it. The result was that again Axiom and async-std was faster, and it is faster even if I use this blocking API, the actixweb blocking API, which is this one, actixweb block. When I use this, tide is faster, and when I use this, tide is still faster. So there was nothing I could do in actixweb, no API that I used, no configuration that I tried that made actixweb faster than tide and async-std. Apart from that, what you probably can see here is that we create a runtime here and we use it to run our actixweb application, the server. But as you can see, the server itself, so actixweb itself, creates another runtime. Not runtime, another, let's say, pool, thread pool. So we have the runtime of Tokio with its threads, and we have a second runtime, let's say, the actixweb runtime. And it seems that no matter the configuration or the usage of Tokio, since actixweb creates its own, let's say, thread pool, which I will call runtime, we are not fully taking advantage of Tokio and what Tokio can offer us, the threads of Tokio, let's say. So this is another point. The point is that actixweb creates its own thread pool and uses that to execute the requests. And this also becomes obvious if we come to the documentation here and we check this actixweb block API, which I have here as you saw. This is it. So if we check this one, if we go to the source code, you will see that this function runs our function runs it on the actix thread pool. So we are not using Tokio, and if we search for this, you see that this is a crate. Let's open this, and if we check for thread pool, let's say, let's open this. Yeah, here. This is the actix thread pool, and as you can see, it uses the thread pool crate under the hood. So if we follow this thing here, this is what we at the end use. We use this crate, which uses channels, as you can see. So yeah, the whole point of this is that as it seems, actixweb uses this thread pool crate in order to create its own multi-threaded runtime, let's say, and it is not using Tokio. So in my mind, when I started looking into this, I thought that actixweb would take advantage of Tokio and the threads that Tokio provides, but it seems that actixweb is using its own, let's say, mechanism for multi-threading. So yeah, this is the second point. So as you can see, we don't have a solid answer to our questions because many people contact me through comments or through emails and are very interested in this topic, why there's so much difference between async-std tide and actix-web. The only thing that I can think of is that I will try, first of all, I'm waiting from Carl for some feedback on the latest information that I have provided him regarding Tokio and the benchmarks. A second thought is that I will try to contact Rob, who is the main maintainer of actixweb, to get his point of view on the subject. And the third thing that I want to do is to create, modify, let's say, the warp API that I have used in the past, and use within warp this Tokio spawn blocking, and benchmark the warp implementation with the async-std tide implementation to see if we can get something out of that, because if you remember and if you have seen all the benchmarking videos, you will know that warp is the fastest implementation, is the fastest performing framework regarding these benchmarks. So I will try to improve even further the warp output by using this spawn blocking API of Tokio, and see if we can reach a similar output compared to tide. And I will be waiting for feedback from more experienced Rust developers and people that are involved in the projects themselves. So this was the information that I wanted to share. I hope that it will be beneficial to you, and ultimately what I'm trying to do is to reach a solid conclusion on the subject, because the performance of tide and async-std is quite surprising to me, because I would expect that Tokio would outperform async-std and every other runtime, since it is so much advertised, but not in a bad way. So many people are involved in Tokio, and it is used by Amazon and all that stuff, and I would expect it to be a very solid, as it is, and very performant runtime. So I'm just trying to reach the end of all these questions. So this was the update. Thank you for watching, and have a great day.